Hello everyone. Today we will carry out CFD analysis of a concentric tube heat exchanger with parallel flow options. The main outcomes of this study are: you will learn how to define connection boundary conditions between two fluids that are separated by a solid wall, how to define wall conditions, wall materials, wall temperature of a solid. Then you will define inflow as well as outflow boundary conditions. You will also learn how to define surface goals for temperature at the outlet of a cold water fluid, and how to plot the temperature variations along the length of heat exchanger. And in the end, you will learn how to plot the temperature variations across the heat exchanger. So let's start our study in SolidWorks now. So open SolidWorks and start to make a model of concentric tube heat exchanger. Go to the right planes, and here you should draw two circles. Both circles are concentric to each other. Assign the dimensions to inner circle, that is 50 mm, and the diameter of outer circle is 80 mm. Now exit from sketch, keep this sketch one selected, go to the features and go to the extrude options. Here select the thin feature options and select the thickness of the wall, that is 2 mm, and the length of heat exchanger is 250 mm. In this way, we have make a simple concentric tube heat exchanger that has two tubes, this one as well as this one. Now save your work and start the flow simulation study now. Click on Flow Simulation tab, then go to the wizard. You can give a name or specific name to your study. Here is the project 1. Next. Here you should select the fluid flow as well as connections. And here is the analysis type, that is internal. And from the liquids, add the water. And here is the solid metals, that from which the both heat exchanger shells or tubes are made, that is simple aluminium. Go to metals and select the aluminium. Select the copper. Here is the default outer wall thermal conditions, that is temperature of the wall, that is at 298 Kelvin. So finish. So here is the message. Do you want to open to create lids tools? Yes, we want to create lids. Select the planar faces openings that belong to lids. So select this face, as well as this face. Here the thickness of the lids that is 2 millimeter. Okay. So the model geometry or project setting has been modified. Do you want to reset the computational domain? Yes and no. Just hide your domain. Before proceeding further, we will sketch two lines that will run across the length of this heat exchanger as well as across perpendicular to the length. Again, go to your model, go to the front plane and draw a simple straight line starting from here to here. Exit. So you can ask why you are plotting this line. This line will use to plot the temperature variations across the length of the heat exchanger. Similarly, again go to the front plane and draw a line at the midpoint and perpendicular to the length of heat exchanger. Now again go to your flow simulation study. Here insert boundary conditions. Select the inlet mass flow for the cold water. Select this phase. Right click. Select other. Then select the inner face of this lid and delete first one. And here is the flow rate, that is 0.001 kg per second. And here is the temperature of the cold water, that is at 298 Kelvin. You can make a section view in order to show these flow lines. Again, go to the boundary conditions and select this phase. And the flow rate is 0.05, while the temperature of the hot fluid that is flowing outer side or in the outer tube, that is at 350 Kelvin. After that, we will define the outlet or outflow boundary conditions. Select the pressure openings, environmental pressure. Select this phase, that is for cold fluid, and this phase. Okay. Now you will define the goals, that is temperature goals, that what should the temperature of the cold water during the exit at this phase. Go to the goals, insert surface goals, select this phase, and here select the temperature of fluid, that is the average temperature. Now your settings are almost completed. Now run your study, that is the new calculations. Here you can check the temperature plots. You can see These are iterations and how temperature is varying. That red line is at 350 and the dark blue is at 293. You can see how the temperature of inner tube is changing or increasing as solution is going towards conversion stage. You have to wait until here the finished message appear. Please note how many iterations are needed to converge the solutions. If you have any query, you can ask me in the comment box. So our solution has been completed now. So these are the temperature contours at the front planes. So go to the results. Here are the cut plots. Select the temperature of the fluids at the front planes. So these are the temperature contours along the length of the heat exchangers. Now go to the surface goals. Go to the goal plots. That was the average temperature at the exit of the cold water. Show. You can see the average temperature value is 313 Kelvin. That was at 298 Kelvin in the initial. That has been increased to 313 Kelvin. Similarly, you can plot the temperature along the length. Go to the XY plot. From here, select the temperature of the fluids. Select this line. Show. You can see how the temperature is being changed across the length of the heat exchanger. Select also draw this graph. Again show. You can see the temperature across the midpoint across, and that is perpendicular to length. This is the temperature variation starting from here to 298 going to 335, and here is the wall gap, then come to about here. This is the temperature at the cold fluid at the midpoint, that is 327. So this is the temperature variations. I hope you enjoyed this simulation study of heat exchanger with SolidWorks. Please ask any questions in comment box and subscribe and share my channel. Thank you for watching.